Okay, we're now to part 3 and part 4 of our astronomy notes, and today we're going to talk about the Hertzsprung-Russell diagram, which is the HR diagram. Now we have a lot here that you cannot see, but this will be printed off at a later time, especially for the second test, so we can take a little closer look at this. But a couple key things that we are going to be looking at. Pay very close attention to this side right over here. Up and down in the graph that we see on the HR diagram, this is the absolute magnitude. And we remember from earlier in the unit, the absolute magnitude is talking about how bright a star actually is. Then at the bottom, we have the heat registering from your hottest stars, which are your blue stars, to your coolest stars, which are your red stars. And then when you look at this, you also have your letterings, the O, B, A, F, G, then we have the K and the M. And again, that was brought about by Annie Jump Cannon, who coined the phrase, the mnemonic device, Oh, be a fine girl and kiss me. Then we take a look at the two astronomers, Hertzsprung and Russell. They came up with the HR diagram by putting the stars in a graph, and that's what they did, by temperature and by their absolute magnitude. And in the middle here, we see this is the main sequence, if we were to draw a line in the HR diagram. About 90 to 95% of all stars will lie in the main sequence, and all the main sequence stars are burning this element right here, hydrogen. And we know that hydrogen, when it's burned, we are going to be in that main sequence stage. So obviously, if the sun is right here, we know that we are burning hydrogen. So the sun is burning hydrogen right now. When you look at this diagram, you can also see the high mass stars are going to be at the upper levels. They're going to be very bright stars, and in most cases they're going to be very hot stars. But some of the very bright stars can be very cool stars too. As a star ages and it gets to the red giant or the supergiant stage, just like over here, you can see that it becomes much cooler, but still can stay very, very bright. Okay. When we look at the death of stars, supernova, again, tremendous explosion that is the death of the star and possibly the birth of new stars. Again, there's two things that form after it, the neutron star, and then we also have a black hole, which will become more evident later on in the second test. Now, the last few parts that we're going to talk about today as well in galaxies, there are three types of galaxies. We have the spiral galaxy, we have the elliptical galaxy, and the irregular galaxy. Spiral galaxies have a central bulge and a spiral arms. You can see this because a lot of the times they depict the Milky Way as a spiral galaxy. Elliptical galaxies are massive groups of older stars, hardly any gas or dust. So that means they are very old, and they're going to be that elliptical shape and round, and kind of very hazy in many ways. The irregular galaxies have no specific shape. Really, they don't have a real true order, and we'll talk more about why the irregular galaxies are the way they are in the cosmology section, which is test 2. So we have three different galaxies: spiral galaxies, elliptical galaxies, and irregular. Now the galaxies are all in clusters, and star clusters are groups of stars. So we have globular clusters, which are groups of older stars that can form halos around the galaxies. And then we have the open clusters, which are smaller groups of new bright blue stars found outside galaxies along the spiral plane. really, when you see your open clusters, you know that those are going to be your very bright blue massive stars, which are going to have a lot of new. So that is basically the notes for this unit. The only couple things that I could even mention, you will need to know, we talked very briefly about a refracting and a reflecting telescope. A refracting telescope is a telescope that's going to allow you to see with lenses, much like when you wear glasses to correct your vision. And a reflecting telescope uses the mirror inside the telescope to magnify the image. And really, those are the only two main differences between the refracting and the reflecting telescope. And that is all your notes that you're going to need for the test, which is coming up next Tuesday.